3, 2, 1. Boo! Hello everyone, it's November the 16th. Alright, what do we have today? Oh, it's a hard problem with 26% of acceptance. Ooh, spooky night. Shortest subarray with sum at least k. Given an integer array nums and an integer k, return the length of the shortest non-empty subarray of nums with a sum of at least k. If there is no such subarray, return -1. Return the length of the shortest non-empty subarray. A subarray is a continuous array. Okay. The sum at least k. So I have k. So I want to know a subarray. And because we have negative in it, so I think that can make things a little bit more complicated. Yeah. Because you have negative, that means if you have a subarray, right? Let's say you do sliding window. You give a window and you slide through. None of them is smaller. None of them is at least k. Then naturally you say, okay, I'll make it bigger, but that's not true, because there are negative values. So you have to, yeah, bigger, small, they can both work, right? But that is not the case. Of at least k. So subarray can start from some value. It must start from some value, right? It must start from some value. And when you start from that value, it will be wow, the negative value really make this thing difficult. Really make this thing difficult. That's awesome. Can we, I don't know, DP this thing? Let's say we want to find, but it has to be the shortest subarray. It's not the maximum sum. I think I can smell from here. Can we convert the problem? I don't know, I'm just thinking, you know? I have 2 minus 1 and 2. I want to find something that's larger or equal to 3. Can we add 1 to everybody? So it becomes 3, 0, 3. And we say at least has to be 4. Does that make sense? No, it does not. Because this sum is 3, but this sum is 6. It's not proportional. It is not proportional. We can make it proportional. How? How do we make it proportional? Well, let's say we add the smallest, so everybody become non-negative. And the reason I want non-negative is because when I do non-negative, I can do sliding window, right? Because a sliding window, if it doesn't work, so I can just increase the size or decrease the size. Yeah, I can increase the size or decrease the size. So I need it to be positive, or at least a non-negative. That's what I need. Okay. So basically, if I find the smallest value, I'll add it to every sliding window, so I get a new sum. And when I compare to the k, it has to be k plus this window size, if I call it m, is the window size, times the minimum value. Right? Because you add them together, you're actually adding this more. So you do this and this and compare this. And with this, you can do binary search. Because if this one is good, right, and then we can shrink it. If this one's bad, we can increase it. Okay, that's an idea. That's an idea. We turn every value into a positive value or a non-negative value. Yeah, let's give this a shot. I think this one has it feels interesting. Okay, it feels very interesting, the solution. All right, so what I'm trying to say is we are going to find the minimum of everybody. So I need a min integer the max value, right? And then say for n of nums, min equal to math.minimum n min and n. Okay, so we get the minimum value, which, ooh, this is interesting. This will be interesting if the minimum value is a negative. Does not matter. Does not matter. We just minus this min. Does not matter. Okay, so now what we can do is int low is, dude, -1. Huh. You know what? I think -1 is gonna give us issues, so I just do 0. High is going to be, it could be have to include everybody, right? So usually I do a little bit larger than that. Okay, I do that, and then we'll say while low is smaller than high, mid shall equal to low plus high minus low divided by 2, right? And then that's the size. Now we're gonna sliding window it. What we need to do is find the sum, right? Find the sum. Okay, so int s equal to 0 for int I need the I and j. I equal to 0. Okay, int I equal to 0. So int j equal to 0, j smaller than nums.length, j plus plus. All right. So we always do this, right? And then we say if j minus I. So 0, 1, 2, 0, 1, 2, 3. So this is equal to k. Then I need to say s minus equal to nums I plus plus. Right, this is to make sure that we are within the range, right? And once we do that, we have to check again, right? If j minus, yeah, we'll do again, j minus I plus 1 is equal to k. Not k, mid. I don't know what you're doing. It should be mid. Right? Is equal to mid. Mid is the length. So this just means we have, well, we get too much. So we need to remove the front. And this says if the window size is mid, if the window size is mid and s minus min times mid, right, is, I wonder whether this is even necessary. If I say if min times, everybody have to add that. Honestly, I am not sure. No, I don't think this is right because this will be the same as the other one. But no, because the minimum value is I already specified. You can imagine everything is adding that much. No, I think this will be the same. This will be the same because the target also changes, right? The target also changes. Yeah, I don't think this is right. This is not right. How about it's because the negative value, right? That's giving us trouble. How about we group the positive values first and then compute the sum? You know, we just group them together, right? If we have a positive, and we'll pass this. So we calculate the total sum, right? And we will check if the total sum is smaller than k, then yeah, it's no good. You cannot do it. That's fine. We'll just keep going. If the total sum is larger or equal to k, then that stretch itself need to be considered separately, right? And then we can do the regular sliding window to deal with that. So yeah, so we'll do that. So that part will be sliding window to get the smallest. I wonder if there really is a better way to do that. I think there might be a better way to do that. Like, cause I can say starting from this position, how many do you need to add in order to reach there, right? So if we start from a position, and if I know, you know what, let's just do sliding window. It's fine. We just sliding window it so we can find it, right? And under a case where all of those, right, combine, all the positive value combine, they none of those positive islands can satisfy. Then you need to basically combine multiple positive with a sacrifice of a negative in between, right? So because at the end, what we're gonna have is some positive, bunch of negative, another positive, something like this, right? And neither of the positive, none of the positive itself is larger or equal to k. So now we just see, can we combine this? And we have to add all of these together. So yeah, so we have to then become a positive, negative, positive, negative, positive, negative, a positive, negative, like that, right? So when that happens, I need to also know the index. Holy crap. It is more complicated. So it's gonna be, I need a start, I need a value, the sum, right? Sum, and then I need a start and I need an end. Sum star end, sum star end, sum star end, right? And then what? Then you're gonna say, I'll check this. I actually think then you can do binary search, because if this one doesn't work, then your only chance is to expand it, because otherwise there's no way. You cannot shrink it. Shrink it definitely, because you need more plus, right? You already got pairwise plus, so it's the only way is to make it bigger, right? You need to make it bigger. Make it bigger, and also and if it works, to make it smaller. Okay, we'll make it bigger, and then we make it smaller, but it has to be, the size has to be a odd number. It cannot be even, right? Because if it be even, it actually gets smaller, so it has to be an odd number. And it has to start with a plus, right? It has to start with a plus. So if we have some negative at the front, just ignore it. I don't need a start and end. I just need a total number. So it's just gonna be, no. I just need a sum and a count. Sum and count, sum and count, and sum and count. Right? And I'll do, we can do this together, and then we'll move forward 2 positions. Right? So we'll deal with this, minus this, plus this, so we check. Okay, so, this will be interesting. So none of this will work. Very funny. Alright, so what are we trying to do? Okay, I need a list of int combined array list. Okay, and then what we're gonna do is go through this. So we go, negative, so it's negative. Yeah, we do sum. Okay, sum. I1 if, how do you check their sign? Nums I times nums I minus 1. What if it's a 0? Well, 0 doesn't matter. You can do whatever. Okay, you can do whatever. So I just say if it's large or equal to 0. Okay, so they're the same. Actually, let's put it in the positive. If it's larger or equal to 0. Yeah, it doesn't matter. 0 doesn't matter. So if it's larger or equal to 0, it means they're the same sign. If they're the same sign, then do I also need counter? Right? If they're the same sign, that s plus equal to nums I c plus plus, right? Else, now if I and I minus 1 is not the same sign, okay, one is positive, the other is negative, or the other way around, then the previous one need to be added into combine. We're going to say combine dot add new int. We need its sum and we need its count. Okay, once we've done that, what we're gonna do is alright, I want to use a deck. I think a deck will help my case more. Right, so we'll add this and sy equal to nums I, because I didn't use it, cy equal to 1. Okay, so once this is done, you say if combine, right? Oh, dog it. Holy crap. It cannot do the other. Oh, it has to be. Oh my god. My god. It cannot be deck. It cannot be deck. Has to be a list. That's alright. When you do a list, we just simply cannot remove the start. That's alright. That is totally alright. Alright, here, if s is larger than k, No, integer, because I want a minimum, right? So I need a function, private int helper1. Let's give you a better name, which is positive subarray. Yeah, I'll just call it helper. And nums start and actually you don't even have a start, you don't have an end. I have a length, I have an end, that's what I have, and I have a k. Okay. So first thing, start shall equal to end. Okay, 0, 1, 2, 2 minus length plus 1. So I have a start and I have an end. So within this range, I need to do binary search, right? So low, actually I can just go directly. This is low. High should be end. Oh, why do that? You can just call it high. Right, so now I have low and high. While low is smaller than high, right? Int mid, low plus high minus low divided by 2, and then int s equal to 0, and int I equal to 0 for int j equal to low, j smaller equal to high. Okay, j plus plus s plus equal to nums nums j. Okay, and if j minus I plus 1 is equal to mid, yeah, no, it's just j minus I is equal to mid. In that case, we need to say s minus equal to nums I plus plus. If j minus I my plus 1 is equal to mid, right? It means we can do the comparison. If s is larger equal to k, right? So in this amount of length, it's already good, so we shrink. So high equal to mid, else low equal to mid plus 1. So s is still smaller, so we have to get it bigger. Ba 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 boop. Ba ba boom ba 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 ba. So yeah, we handle this. J move forward, add a new one, and it's still J. Yeah. So we do that, right? Going through the whole thing. Once we go through the whole thing and then get out, I have actually this is not right. My bad. I have no idea what I was doing. What this says is if this is good, we have the length and s is larger equal to k. Boolean exists. Right, this I always say exists equal to true, because this one, the current one, it works. and I'll break it. So we go through the whole thing, and then we say if exists, then we can try to shrink it, right? So we say high equal to mid. Otherwise, we say low equal to mid plus 1. There we go. That is the binary search. Okay. So that's the binary search, and then at the end, if it exists, if it does not exist, low equal to mid plus 1, right? And it gets out. So low is the smallest. Low is the smallest. Then I'm gonna return low, right? So low is the smallest. So we say if this is larger than this, then I'll say res equal to max, so maximum res helper. Helper what? Helper is going to be helper nums. Length shall be C, and high. Oh, interesting, because this is when the current is different from 4, right? Current is different from before. So cannot do I. It should be I minus 1, and this is K, right? So yeah, so we get a res updated, and then we keep going. And at the end, we'll check if res is smaller than integer dot max value, which means one of them already happened. Then we just simply return res. Otherwise, then we have to handle this combined thing. Okay, combined thing. Combined thing is the same. Index, right? We have to I mean, I guess it's fine if we have negative up front. We just do it. It's gonna be like this. You might have a negative here, you might have a negative here. We just do one, and then it will make things a lot easier. Like seriously, it will make things a lot easier. We just add them together, and then we check, right? We just check, and every time we do add 2, right? So we do another round of low. We call low equal to 0. This is not right. I think I got low and high wrong. Low and high should be the length. This is just integer. It should be start. This should be end. These are integers. These are indices. Right? You have start and end. And low and high is a different story. Low and high. So low shall still be 0 because this is the length, right? High shall be basically length plus 1. So if mid is the length, so J shall start from start, and this should be end. I should be start as well, right? Yeah, each time always start from the start, and then we have terminate at the end, and then we say J minus I is equal to the mid. Yeah, plus 1, okay. And as long as one of them exists, then we can try to shrink it. What if it doesn't work? What if low is 0? It will happen. Low is 0, which means we cannot identify. That's not true. It will not be 0. It will not, because we already identified this is larger equal to k. You will definitely have subarray. It will work, right? It will definitely work. So low will not be 0. Okay, so here is the actual deal. It doesn't really matter. We have a low and then we have a high. High, I believe I will do combine dollar size plus 1, while low small and high mid equal to low plus high minus low divided by 2. Same exact thing here. And then we also need s equal to 0, right? Int I equal to 0 for int boolean exists equal to false, int j equal to 0, j smaller than combine dot size j plus plus s plus equal to combined dot get j 0, right? So that is s, and the mid has to be okay. So we shall say if mid mod 2 equal to 0, so like if it's 2, that should be 3, right? So mid or plus plus. If it's even, we'll make it odd. Okay, so we'll do s plus equal to same thing. If j minus I is equal to mid, then s minus equal to combine dot get I plus plus 0. Right, and then we say if j minus I plus 1 equal to mid, and s is larger or equal to k, then say exists equal to true, and I'll break. Oh, holy crap. We have to compute the actual size. Well, we have to compute the actual length. I cannot use this mock length. All right, scratch that. I don't think it's a binary search. It shall be a two-pointer. It shall be a two-pointer. It shall be a two-pointer. Yeah, this shall be a two-pointer. Start and. Right. We have to have s, and with s plus equal to nums j. Right. While s is larger than k, we can add this, add. Every time I add, if it's larger than k, then I start removing. Right? If it's larger than k, s minus equal to nums I plus plus. When it gets out, s is just smaller. Right? It's just smaller. That's actually not true because you are not quite sure. I think I need to be while s minus nums I is larger equal to k, right? If I remove this, it's gonna be still larger equal to k, then I remove it. Right? I remove nums I and I move I forward. And I try it again. If it's still larger equal to, then I remove I, right? Until at a point where s minus nums I is not going to be larger equal to k, right? When it's not going to be larger or equal to k, then we'll jump out, which means I don't remove it. Then I to k is the current, right? I to k is the current. Now we can go res equal to integer dot max value, and I can say res shall equal to max dot minimum res and j minus I plus 1. That's the length, right? And then every time I extend, and I will remove, extend and remove, it doesn't matter. Eventually the effect of this, oh no, this is not good. The effect of this is I don't need all the way to 2020. So all of these can be deleted. It's no low, it's just a result. Right? So this is within a positive. This is still fine. And here again, we'll do exact the same thing. Okay? So I gave I equal to 0. Yes, I equal to 0. And for I already have res, right? And I already have s. So I reset s equal to 0. And count. I reset count to 0. Okay. Now for int j equal to 0, j smaller than combined dot size j plus plus, same thing, s plus equal to combined dot get j, we should say 0, count plus equal to combined dot get j 1. Okay, once we do that, we say while s minus combined dot get I, what the hell happened? I 0, right? If it's larger than k, then we say s minus equal to combined dot get I plus plus 0. Ooh, we also need another part, which is remove c minus equal to combined dot get I 1. Let's now do this 0 0 trick. Let's do I plus plus here. Right? So while this blah blah blah, and then once it gets out, we can say if s is larger than k. I forgot this condition. If I need this condition, if s is larger than k, yeah, then you do that. Right? If s is larger or equal to k, then the sum is good, then you do it. Otherwise you don't do it. So rest could be like maximum, which is fine. And again, this is s. If it's larger or equal to k, then what we're gonna do is call it res equal to math.minimum res and what? And I think it's c. C is the number of elements. Right, c is the number of elements. But if that's the case, why don't you just go directly using this? Why you make it so complicated? Why can't you just two-pointer it directly? Well, because you go, you get something positive, right? And you need to remove the left. You say you need to remove. Hold on, let me think. What's the reason why you need to do this way? What prevents you from doing it the other way? I don't understand. F2, -1, smaller, right? You just keep going because it's smaller than this, so you don't keep going, and this is 3, and you say, yeah, I don't understand. Why you have to make it so complicated? Why two-pointer cannot work on this? I don't know. I do not understand. Maybe I'm wrong. Maybe I don't know. Maybe I'm just not thinking straight. Like I don't. I don't understand, honestly, why a simple two-pointer will not work. Why? Okay, so this is something I don't understand. Is this... Right, this is something I don't understand. I feel like we shall be able to use 2 pointer to do this. Nope, we cannot. Why? Because you have a negative. So as you go through, minus this will never be larger equal to k. Unless you add... yeah. Yeah. Okay. Okay. Duly noted. So yeah, this one does not work. But it's fine. I mean, I was never expecting this one to work. I'm just curious why it does not work. But now I think I understand why it does not work. So we go back to this, right? So we have this. Everything's fine. This is fine. This is fine. What I need to do is, so I can have a negative at the front, right? So basically negative plus, or positive, negative, positive, negative. So I do the first one, and I'll add something, and then I'll minus something. Actually, no. I shall actually just go with the positive, right? And every time we'll add 2. Okay, we'll add 2, and after I add 2, now I check if it's minus the first 2, right? Is that good? Right, you have to, so plus minus need to be combined. Oh, it may be minus plus. What if it's minus plus? Then you already, if minus plus is working and plus itself is already working, right? So it has to be plus minus plus, right? It has to be, because each plus itself does not work. So you have to combine 2 pluses together and sacrifice something in between, right? So you do plus minus plus that. If yeah, you do, so you start from, holy crap, you start from this, you add a minus plus, okay? You add a minus, you add a plus, you check if it's good, right? You check, and then when you reduce a plus minus, right? You reduce a plus minus, because if you do a plus, that doesn't make any sense. You reduce a plus minus. Okay, so in that case, this is going to be interesting, right? Yeah. So I need to start with a plus. Maybe I can even change this, you know. I shall say if combined dot is empty, is combined is not empty, right? Or combined is empty and your s is larger or equal to 0. Only in these conditions do I get combined. Or if it's not empty, then I do it, right? If or s is larger or equal to 0, it's positive, I'll add it, right? So if it's not empty, I'll always add it, and then blah 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 when we're done. So when we're done, we can also say, yeah, it's okay. So now we guarantee, right? So guarantee, ensure that the first combined, the first element, the first sum in combined is always positive, always non-negative. Okay. Now I can do this, I can do this, I can do this, I can do this. This I think should plus equal to 2. Because every time you don't want to move to a negative. And what's the point of move to a negative? Every time you start from this, right? You add 2, you add a positive and a negative. Actually, no, you should add, you start from here and then you should add a negative positive, right? A negative positive, that's what you add. Okay, and when you check, you should check a positive and negative. Remove both. If you can remove both, you remove both. And when you add, you should add a negative and positive, right? Okay. Okay. So where should J be then? Can we make it simpler? So we extend. We extend was good. Okay. Then we remove. Okay. So I always point into the positive one. Okay. And then J. What should J pointing at? J should always point. They should both pointing at the positive one. And our plus equal to this. Oh no. J should be. Where should J pointing at? little bit tough to do. So on your minus, you need a minus plus minus. On your plus, you need a plus minus plus. Right, you do that. J is standing on here. Okay, I is standing on here. Then you can compute the totals. Right. And then once you're done, every time J, you need to add this. Okay. So yeah, let J stay out here. So we will say if combine dot get combine dot size minus 1 0 if it's smaller than 0, choice is smaller equal to 0, then combine dot remove index combine dot size minus 1. So this is ensure that the last in combined is always positive. Yeah, every time if it's a 0, it will be picked out. So 0 will be, completely picked out. So this one I can just say is always positive. Okay. So as long as I can do that, it's smaller than its size. You can say j plus 2. J plus equal to 3. Plus 1. No, plus equal to 2. J plus equal to 2. I'll say yeah, because every time we will add, J will always go forward 2 times. So we add all those. Now we have whatever's in this range, right? Whatever is in this range. Then this has to change by now get 0, 0, 0, 1. Right, so I have SN count. Okay, so now we know this is smaller than k. And then we added this is a negative and a positive, negative and a positive, right? So we say if this is minus equal to, well, of course, I is here. So when minus equal to I minus combine dot get I plus 1, 0. Minus those two, if it's this, then we'll say plus combine dot get I plus 1, 0. Plus combine dot get I plus 1, 1. So I remove those. I also plus equal to 2. Plus 1 plus 2. Right? So it's I and I plus 1. So I will move forward. And then if this, it will be this. And I don't know, return this. Ooh, out of bounds. What, really? Wait, what? Which one? The first one? Oh. Is this one? If I see, if S is larger than 0, then we'll do that. This is not necessary. Right? Jump out. If smaller than integer dot max value, Lord. First one. First was 1 and 1. Yeah, because I didn't check it. I see. Okay. So, if s is larger, you go to 0. I'll do this one more time. Okay. Try it again. The hell? C is 1, S is equal to 1. This jump. S larger than S larger equal to K. Yes. Nums. C is 1. This should be 0. Okay. This is 0. 0 minus 1 plus 1 is 0. Start is also 0. So I is 0. S is 0. J is 0. 0 small equal to 0. This S is equal to 1. 1 minus 1 doesn't do it. Larger equal to should be 1. Return rest should be 1. Right? Rest is 1. Huh? What the hell? Yeah, it's 1, 0. S should be 1. Yep. No, it's not larger equal to K, but K is 1. Don't do it. S is larger equal to K, so. Okay, rest is 1. Oh, this is min. I should say max. It's a weird error. Alright, let's try this. Highly convoluted. Nope. Okay, so we're not gonna do this anymore. We're going to check the solution and I'll copy and paste. Yeah, it doesn't work. It took too long. I tried. Have to. There's no way other than we highlighted it. We just need to submit it to make sure that it passes, and we'll deal with it some other time. Okay, so it was bad, but it's fine. It happens. We can think about it again. Think about it again. Basically, you will do that. Actually, you don't even need to do this. So we just, delete it. Right, we deleted. And actually, I like to have my original one. Alright, this one fail. Doesn't work. Does. Does not work. Alright, that will be it for today. We'll have to think about it some other time. Alright, I'll